All right, good morning and welcome to Master Talker online class. In today's video, we'll be talking about the gas laws, right? The gas laws, okay? So first of all, before we talk about the gas laws, we'll be talking about, all right, a gas is defined as a substance that expands to fill the container uniformly, okay? Now, we have four quantities that are very important in all experimental works, measurements, and calculations involving gases. The four quantities that we look at is the first one is the volume. Number one, number two, pressure. Number three, temperature. And amount of substance. That number of mole, sorry, number of mole. Number of mole. Okay, so let's pick the first one, volume. All right. The volume of a gas is the size of the space it occupies, right? Which is the capacity of its container. The SI unit of volume is volume is measured in meter cube. Okay. Although there are other units of volume, a unit that is rather too large for most laboratory purposes. The practical unit of volume is this volume is too large. If you leave your volume in meter cube, it's too large for chemical this thing. What is it called? Experimental lab experiment purposes. Okay. So what do we use? We use some other SI units of volume, other SI units of volume, other units of zone, not SI unit. SI unit is the standard one, which is meter. So other units of volume is what? Cm cube. Okay, Cm cube. Another one is dm cube. Then another one is liter or liter. These three very, very important. Okay. Don't forget that dm cube is something as liter. Please note, dm cube is the same thing as what? Liter. So you should note, very important, that 1 dm cube is the same thing as 1 liter. So if you want to buy fuel, so tell them to give you 1 dm cube. If you don't want to say 1 liter, if you want to buy 10 liters, tell them to give you 10 dm cube, 1 liter. Okay, so 1 dm cube is equal to 1 liter, and it's the same thing as 1000 cm cube. It's the same thing as 1000 cm cube. So please, you need to note all these things, or you can say 1000 milliliter. 1000 milliliter. So milliliter and cm cube is the same thing. Note, milliliter is equal to cm cube, while liter is equal to dm cube. Please, very, very important statement to note. All right. So that is that for volume. So another thing we'll look at is temperature. Pressure. Number two, pressure. Number two, pressure. All right. Pressure is defined as the total force exerted on a surface divided by the area of that surface. That is pressure. Pressure is equal to what? Force over area. That is pressure. All right. So the force per unit area is same thing as pressure. Now the SI unit of pressure is Pascal. The SI unit, the standard one, the SI unit of pressure is what? Pascal. Because the man called Pascal is who found about pressure. So we call it PA. Sorry. So that is that. Though we have other ones, There's another one called kilopascal. No, kilo means 1000. 1000 pascal. So, or kilopascal. All right. So now, another thing you need to know that there are other, or Newton per meter square. Please note that Pascal is something as Newton per meter square. Pascal Pascal is same thing as what? Newton. Newton per meter square. Okay, let me write it. PA. Pascal is equal to Newton per meter square. Pascal. Okay. How do we get the Newton per meter square? Force is in Newton. Area is in meter square. So Pascal is same thing as what? Newton per meter square. There are other SI units of what is it called? Of pressure. We have the ATM. It's measured in ATM. It's equally measured in bar. Okay. It's equally measured in bars. It's equally measured in torr. Is equally measured in torr. Torr. Is equally measured in torr. Is equally measured in millimeter mercury. Millimeter mercury. Hg. Okay. Is equally measured in millimeter mercury. Please, you need to know that another word for millimeter mercury is torr. The same way we have that Pascal is the same thing as Newton per meter square. You need to know that torr is the same thing as what? Millimeter mercury. Please, these things are very, very important in your calculation. If they tell you Pascal, it's same thing as telling you Newton per meter square. If they tell you torr, it's same thing as what? Millimeter mercury. So we need to know that one ATM is the same thing as bar, please. And then finally, ATM is the same thing as bar. Okay. So whenever you hear bar, it's same thing as ATM. Whenever you hear torr, it's same thing as millimeter mercury. If you hear Pascal, it's same thing as what? Newton per meter square. So now we need to know that one ATM is the same thing as one bar, because bar is the same thing as ATM, is the same thing as one bar. Okay, which is the same thing as 10101 325 millimeter mercury, which is the same thing as what? 760 what is it called? Sorry, 760 millimeter mercury. So this one is millimeter mercury. Why this one is uh Pascal or Newton per meter square. Yes, Pascal or Newton per meter square. Pascal. PA. Right? So another thing is that sometimes if they don't want to write it like this, they write it 1.01325 times 10 raised to power 5. If you count it 1, 2, 3, 4, 5 Pascal. All right. So that is that. Okay. So sometimes they will not ignore this because this is approximately one. One times this is something as this. Sorry, Pascal PA. Okay. Sometimes they will ignore this one and just write 10 raised to power 5 Pascal. It's the same thing. Okay. So these are little things you need to know. All right. Any other thing? Okay. So let's do some calculation on this. Let's do some calculations on this. The first one said convert. The first one said convert. Would have done calculation on volume that we did before. Okay, convert or let me write everything and then we'll start doing the calculations. Okay, let me write all, then we'll now start doing the calculations. So number 3, temperature. Number 3, temperature. Right. Number 3 is temperature, and then we have that right, temperature is the property of matter. Okay, in the case of gas, which reflects the quantity of energy of motion of the component particles. It is a comparative measure of how heat or cold a material is. The coldness theoretical temperature is called the absolute zero. The absolute zero. Now, for gas law, it is important to use the Kelvin scale of temperature. Celsius temperature T can be converted in Kelvin. Now, they said normally the SI unit, you need to know the SI unit of temperature is what? Degree Celsius. But we don't use degree Celsius, please. Always use Kelvin. Another unit, another unit, and the most important unit is the Kelvin. So anytime you are doing calculation involving temperature, that is in gas, in ideal gas, we use Kelvin. And we need to know that to convert a temperature from degrees Celsius to Kelvin, just say that degrees Celsius given to you plus um, that temperature, sorry, to convert from to convert it to Kelvin, temperature in Kelvin. If you want to get temperature in Kelvin, just say that temperature in degrees Celsius plus 273. Very simple. Okay, plus 273. That is how to get that. So the last one is what? Number 4. And that number 4 is what? The number of mole. Number 4, number of mole. Number of mole. Number of mole. And for number of mole, they said the mole is the unit used for measuring the amount of matter in terms of the number of particles. The number of specified particles present in 1 mole of any substance is equal to 6.02 times 10 raised to power 23. Okay, you should know that one mole 1 mole is equal to what? 6.02 times 10 raised to power what? 23 particles. 23. Okay. So that is that. They say the number of particles present in 1 mole of a substance is 6.02 times 10 raised to power 23. Okay. Then I write for you. They say that what? 1 mole of any gas at standard temperature and pressure is occupies a volume of 22.4 dm cube. Okay, we will still talk about our standard temperature and pressure. We still talk about that. So that is that. So the next one we'll talk about is now the standard temperature and pressure. The standard temperature and pressure before we now do the calculations that are involved in the calculations that are involved. Okay. All right. The next one I want to talk about is the standard temperature and pressure. Before we do or let's just do the calculations before that standard temperature and pressure. All right. They say convert. Number 1 said convert 2 atm to what? Millimeter mercury. Anytime you hear millimeter mercury, what should come to your mind is 760. So solution is very simple. Just tell them that 1 atm is equal to what? 760 millimeter mercury. All right. So therefore, 2, put it inside of atm. 2 atm is equal to what? X millimeter mercury. Then you cross multiply. If you cross multiply, you will have that what? This time this, you have what? X millimeter mercury is equal to what? 2 times 760, which is what? 152 1520 millimeter mercury. All right. So that is that. Another example. Question number 2. Please, another word for millimeter mercury is what? Another word for millimeter mercury is what? Huh? Another word for millimeter mercury is I think is Thor. Yes, please. Another word for millimeter mercury. You need to note this thing. These things are very important. That Thor is the same thing as what? Millimeter mercury. Okay. ATM is the same thing as which one is ATM? Can I remember? Okay, Pascal. Don't forget that his name Pascal. Pascal is the same thing as the normal SI that you know, that is Newton per meter square. Okay. The next one we need to know here is that any other one? ATM is bar. Yes, the last one, ATM is bar, please. Yes. So if they don't use ATM, they will use bar. So number 2 said convert 900 millimeter mercury to bar. Okay, solution. So don't forget that bar is ATM. So you tell them that 1 bar is equal to what? Whenever you hear millimeter mercury 760 is equal to 760 millimeter mercury. So therefore, I'm looking for X bar. So it's equal to what? 900 millimeter mercury. So if I cross multiply, I will have that what? I will have that 760x is equal to 900. So therefore, x is what? 900 divided by 760, which is what? That is 1.18 bar or ATM. So bar is the same thing as ATM. Please note that. Okay. So the next one they say convert. Number 3, they say convert 500 Thor. 500 Thor. Please note that Thor is same thing as millimeter mercury. 500 Thor to Pascal. Don't forget that Pascal is Newton per meter square. You will tell them that what? One Thor or 1 ATM. Sorry. Say convert what? Millimeter mercury, okay? And I told you anytime you hear millimeter mercury is 760. So solution. Millimeter mercury is same thing as Thor. So you should know that Thor is same thing as millimeter mercury. Hg. Okay. So and I told that anytime you hear millimeter mercury, 760 should come to your mind. So 760 millimeter mercury or Thor. Let me use Thor that they used. Thor is equal to what? Anytime you hear Newton per meter square, which is Pascal, tell them that Pascal is same thing as Newton per meter square. And anytime you hear Newton per meter square, is 101,325. 101,325. Or you just say 10 raised to power 5. Sometimes you can use 10 raised to power 5. You will still get the same thing. They will understand because it is approximately 10 raised to power 5. If you convert everybody here to zero approximation, you get 10 raised to power 5. Okay. So, but if you can remember this one is better to use. So, which means I have 500 Thor is equal to x what? Pascal. X Pascal. All right. So, therefore, if you cross multiply, you have that what? 760 is equal to 101,325 times 500. All right. X. So, my x I'm looking for is now 101,325 times 500, then divided by what? 760. So, what do you have? You will now be having you will be having uh 66661.2 Pascal. And Pascal is the same thing as what? Newton per meter square. Please don't forget that. Okay. The last one we're going to do for pressure said convert. Number 4, convert 5 ATM. And don't forget that ATM is something as bar. So 5 bar, convert 5 bar to Pascal. And Pascal is something as what? Newton per meter square. So solution. Don't forget that ATM is always 1. So 1 ATM or 1 bar is equal to what? Pascal is always 10 raised to power 5. Or you say 101,325. Okay? Pascal, that is Newton per meter square. If you remember Newton per meter square, you will now know that is what? 10 raised to power 5 or 101,325. So I have 5 bars is equal to what? X Pascal. X Pascal. So therefore, x will now be what? 101,325 times 5. So which will give you 506,625 Newton per meter square, or we call it Pascal. Okay, so that is that for that. So let's talk about volume. Okay, volume in cm cube and volume in dm cube. So how do we do that? Okay, don't forget that liter is same thing as dm cube. So the first question, number 1, said convert um 5 liters to cm cube. Convert 5 liters to cm cube. You know the normal SI unit is meter cube. So solution. So we should know that 1 liter is something as 1 dm cube, which is 1000 cm cube. All right. So therefore 5 liters will now be x cm cube. So therefore x that I'm looking for will now be 5 times 1000, which is what? 5000 cm cube. Very, very simple, right? So the next one we should look at is number two. Number two conversion. Number two conversion. Number two for volume. I'm still at volume. Number two said convert uh convert 600 cm cube to liters, or to dm cube, all right. Solution: you still tell them that what, that 1 dm cube or 1 liter is same as what, 1000 cm cube. So therefore, what do we now have now? X dm cube that I'm looking for is equal to 600 cm cube. So if you cross multiply, you have that what, 1000 cm cube is equal to what, sorry, 1000x. 1000x is equal to 600. So therefore my x will now be what, 600 divided by 1000, which will give you this 0.6 dm cube, or liters. Okay, so that is that for volume. So now let's talk about for temperature. For temperature, before we not enter Boyle's law. Okay, for temperature example, they say convert 7 degree Celsius to Kelvin. Convert it to Kelvin. Solution: you will know that what, temperature in Kelvin is equal to what, temperature in degrees Celsius plus 273. So therefore, I will say they gave me this one in degrees Celsius, which is 7 plus 273, which will give you what, 300 Kelvin. Very, very simple. 300 Kelvin. All right. So the last but not the least here, the last but not the least will now be convert 275 Kelvin to degrees Celsius. Solution: very simple. We know that what, temperature in degrees in Kelvin, okay, is equal to what, temperature in degrees Celsius plus 273. Temperature in degrees Celsius plus what, 273. So I now write this one: 275 is equal to temperature in degrees Celsius that I'm looking for plus 273. So this one moving here, I will now have what, 275 minus 273 is equal to temperature in degrees Celsius. So temperature in degrees Celsius is equal to this minus this to give you what, 2 degrees Celsius. Very, very simple. So I think I'm going to stop here, so that in our next video we'll now enter the gas laws. That is the Boyle's law, the Charles law, and the rest of them. So don't forget that Boyle's law, Charles law, Graham's law, which other law? All those ones talk about what, the physical properties. They looked at the physical properties of gas, while Gay-Lussac's and Avogadro's talks about the chemical properties of gases. So thank you very much for watching. Please like, share, and subscribe.